Our exploration today, it starts not with, some big celebration of tech, but actually with an act of, well, pretty serious professional defiance.
That's right. Picture this. It's Munich, March 1943. And the whole story really pivots around this young guy, a bit nervous probably.
Yeah, holding a rolled up technical drawing.
Exactly. And this drawing, it flew directly in the face of explicit orders from the very top, from the Reich Aviation Ministry, the RLM. He was about to completely ignore a state command.
And this wasn't like, forgetting to file a report.
Oh, absolutely not. This was a direct technical violation. I
Yeah.
mean, you have to understand the context. Nazi Germany, wartime, the RLM's rigid control. Nonconformity wasn't just frowned upon. It could be incredibly dangerous.
So who is this guy?
His name is Hans Mutka. He's a junior engineer working late in the Messerschmitt design office. Think about it. Probably long after the senior guys, the big names, had all gone home.
And what's so rebellious about his drawing? What's on it?
Aerodynamic heresy, basically. His calculations, his pencil lines, they showed wings swept back, a very specific angle, 18.5 degrees.
Okay, 18.5 degrees. Why is that heresy?
Because Willy Messerschmitt himself, the head of the company, and the entire RLM bureaucracy had laid down the law.
Hmm.
The world's first operational jet fighter, the ME-262, had to have straight wings, zero sweep.
Yeah.
That was the mandate. The design was supposed to be frozen.
So any change, especially to the wings, was completely off the table.
Completely. Ironclad orders. Deviating wasn't just a technical suggestion, it was politically impossible. You have to remember, the ME-262 project was already, well, it was chaotic.
Oh, so?
Huge resources, crippling delays, constant threat of political interference breathing down their necks. So for Mukke, this junior guy, to be secretly redesigning the core element of the aircraft, it was essentially scientific sabotage against official policy.
Wow. So that's our mission for this deep dive then. We want to pull this incredible, almost forgotten piece of history out.
Exactly. Yeah. We need to explore why this forbidden design wasn't just a neat idea, it was absolutely critical. We'll get into how it solved a fatal flaw in the ME-262, a flaw that could have killed the whole project.
And then their irony, right. It worked, but it got immediately shut down, squashed by bureaucracy, by politics.
Tragic irony, yeah. But the story doesn't end there. We're going to trace its hidden global legacy. Because that blueprint, sketched in secret by a junior engineer, it didn't just vanish when the war ended.
Someone found it.
Oh, yeah. It was found, it was definitely copied, and it ended up becoming the absolute standard, the fundamental design principle for pretty much every high-speed aircraft built anywhere in the world after that. We're talking decades of aviation history stemming from this one suppressed drawing.
Okay, let's get into it. Section 1. The crisis that made Mutka take such a huge risk. Right, so to understand Mutka's defiance, we need to rewind a bit. About 6 months earlier, September 1942, Leifheim Airfield. This is supposed to be the high point, the moment of triumph.
Yeah, the ME-262 prototype rolls out. It looks incredible, futuristic, twin Jumo 004 jet engines. I mean, the promise is just immense speed that propeller planes couldn't even dream of touching.
The initial reports must have been amazing.
Like science fiction, probably. They had the power, they had the acceleration. But then, very quickly, reality hits. The airframe, specifically the wings, just couldn't cope with the physics of that speed.
The power was too much for the design.
Exactly. The revolutionary engines were exposing this catastrophic aerodynamic problem. The plane became unstable. Frankly, it became terrifying to fly at the speeds it was designed for.
And we know this from the test pilots, right? Our sources really paint a picture. You mentioned Fritz Wendell earlier. He becomes key later. Imagine him climbing out after a high-speed run.
The reports are stark. As soon as the plane pushed past 500 kilometers per hour, roughly 310 miles per hour, it started shaking violently. Severe vibrations.
That sounds bad enough, but it got worse.
Much worse. And more dangerous. The controls would suddenly stiffen up. Pilots described losing all feel, all responsiveness. It's like the plane stopped listening.
And then the really deadly part.
The nose pitched down. Violently. The aircraft would actively try to force itself into a dive towards the ground. Suddenly, the pilot isn't flying the plane. They're fighting this huge, invisible force trying to make it crash.
So they'd hit this invisible wall in the sky.
Pretty much. They'd reached the absolute limit of that straight-wing design. It just couldn't handle the aerodynamic forces at those speeds.
The engineers gave it a name, didn't they? This phenomenon.
They did. They called it compressibility, a rather dry term for something so violent.
Okay, compressibility. Why was this specific issue, the shaking, the control stiffening, and especially that nose-down pitch, why was that potentially fatal for the whole ME-262 project?
Well, think about what compressibility actually means at a basic level. The air itself is starting to behave less like fluid and more like something getting compressed, almost solid at those speeds. Now, for a fighter jet, what's its main advantage? Speed. Speed is everything. Offense, defense, survival. If you can't safely fly faster than, say, 500 kph without the plane trying to kill you by diving into the ground,
then it's not much of a fighter.
Exactly. It can't perform high-speed maneuvers, it can't intercept bombers effectively, it can't escape enemy fighters. The Allies already had propeller planes pushing close to those speeds. The whole point of the jet was to operate in a completely different performance envelope, way beyond reach. This flaw made that impossible.
So the Messerschmitt engineers, they see this, they get the data, they understand the physics, they go to the RLM, the aviation ministry, and say, look, the jet engines are amazing, but these straight wings are a massive problem. What happens next? Did the RLM say, okay, top priority, redesign the wings?
No. They did pretty much the exact opposite.
Really? What was their solution?
It was a classic bureaucratic fix for a fundamental physics problem. Their order was simple. Just don't fly that fast.
Slow down.
Yep. Limit the operational speed. The official mandate came down. Maximum operational speed, 480 kilometers per hour. That's it. Stick with the existing, known to be flawed, straight wings. Focus all your efforts, they said, on reliability, fixing the Jumo engine teething problems, getting production up to speed. Don't touch the wings.
That seems counterintuitive. Why would they deliberately limit the plane's main advantage?
It really speaks volumes about the immense political chaos surrounding the project at that time. Our sources show Willy Messerschmitt was, frankly, exhausted. He was politically weakened.
Why weak?
Well, remember the ME-210, the previous big project. It had been a disaster, a costly, embarrassing failure. Production of the ME-109, their main fighter, was falling behind schedule. The new jet project, the ME-262, was just sucking up engineers, materials, money. Huge resources.
So in that climate, suggesting a major wing redesign
would have been seen as totally irresponsible. Imagine going to the RLM, already furious about delays and costs, and saying, actually, we need to pause everything and spend maybe another year redesigning the wings from scratch. It would have looked like managerial incompetence, possibly even sabotage of the war effort.
And then there was the ultimate wild card, the political interference from the very top.
Right. Adolf Hitler. He kept meddling. He wasn't an engineer. He didn't care about compressibility or wing theory. He saw speed, and he became obsessed with one idea: turn the ME-262 into a bomber. A Schnell bomber, a fast bomber.
A fighter jet into a bomber.
He demanded it, repeatedly. This threw constant chaos into the design process. Every decision Messerschmitt's team tried to make about the fighter configuration had to somehow also accommodate, or at least not prevent, this bomber conversion.
So changing the wings fundamentally would have completely derailed the bomber idea too, presumably.
Absolutely. It would halt production lines, require totally new calculations for bomb loads and releases. It would have been politically toxic. It would invite Hitler's direct wrath for causing yet more delays. The pressure was immense. Get this thing flying now, even with flaws, and make sure it can carry bombs. Forget perfecting it as a fighter.
Okay, so that's the pressure cooker environment. Bureaucratic inertia, political fear, direct orders from Hitler, a mandate for straight wings and limited speed. And into this steps Hans Muttke.
Our 28-year-old junior engineer. He's not senior enough to be in those high-level political meetings, but he absolutely understands the physics they're choosing to ignore.
He sees the contradiction.
Perfectly. The official order says don't fly faster than 480. But Muttke's done the math. He knows the air itself is already hitting dangerous speeds over the wing, even at 480. He realizes the RLM solution is driven by fear and expediency, not science. They're ignoring the one thing that could actually fix the plane.
And that's the spark. That's the moment, for you listening, this is where real innovation happens under pressure. He doesn't ask permission. He doesn't write a memo.
Nope. He folds up the official orders, pulls out a clean sheet of paper, probably scrap, as we'll see, and starts calculating. He decides to trust the physics, to trust his numbers, over the entire command structure of the third row.
Incredible. Okay, let's dive into those calculations. What exactly did Muttke figure out?
All right, this is really the heart of it. What did Muttke understand that the stressed-out, politically constrained senior leadership was missing, or maybe choosing to ignore?
He knew the problem wasn't just the plane's speed through the air, right? It was more specific.
Exactly. It was about the local speed of the air flowing over the wing. That's the critical distinction. The air moving over the curved surfaces of the wing has to travel faster than the air moving under the wing, or the plane itself.
That's how lift is generated, the pressure difference.
Right. Basic aerodynamics. But as the plane's speed increases, that local speed over the wing increases dramatically, especially over the thickest, most curved part.
So when the ME-262 hit, say, 500 kph.
Mutka calculated that the air rushing over the thickest part of that straight wing was already accelerating locally to speeds well over 700 kph, maybe even faster. It was getting dangerously close to the speed of sound locally, even though the plane itself was still subsonic.
And the speed of sound is the barrier here. Around 1200 kph at sea level, varies with altitude, but that's the benchmark. What happens when that local airflow nudges Mach 1?
That's where compressibility bites hard. The air molecules literally can't get out of the way fast enough. They start to compress, pile up, creating these massive pressure gradients. And that leads to the formation of shock waves.
Shock waves, like a sonic boom.
Sort of, yeah. Think of it as a tiny stationary sonic boom forming right there on the wing surface. Usually happens just behind the thickest part of the wing, the point of maximum curvature.
Okay, a shock wave forms on the wing. What does that do? That's what causes the shaking and the loss of control we talked about.
Precisely. That shock wave is aerodynamically devastating. First, it violently disrupts the smooth flow of air. Right behind it, the boundary layer separation. This kills lift almost instantly over that part of the wing.
And that loss of lift feels like?
Violent shaking, buffeting, the whole aircraft starts vibrating. But that's not even the worst part. The really dangerous thing is that the formation of the shock wave dramatically shifts the wing's overall center of pressure rearward.
Center of pressure. That's like the balancing point for all the aerodynamic forces.
Kind of, yeah. It's the point where all the lift and drag forces can be considered to act when that point suddenly shifts backward towards the tail.
Ugh, that makes the nose heavy.
Exactly. It creates this massive, uncommanded pitching moment, forcing the nose down. This phenomenon later got a name, Mach tuck. That's what was making the controls feel stiff, too. The pilot was physically fighting this enormous aerodynamic force, trying to push this stick forward and the nose down. That was the killer flaw the RLMs had to just avoid by flying slower.
So the basic physics, the ideas about compressibility and shock waves, they weren't totally unknown, right? They were probably in textbooks.
They were known, yes.
Yeah.
The principles were understood, but mostly in a theoretical context or in relation to propeller tips going supersonic. And textbooks were written for planes topping out around maybe 400, 450 kph. Nobody had really grappled with these effects on a whole wing at the speeds the ME-262 was achieving, pushing 800, 850 kph.
But Mutka did. He applied the existing theory to this new reality.
He did the math. He looked at the specific airfoil shape of the ME-262's wing, its thickness, its curvature. And he calculated that, yes, absolutely, at speeds around 850 kAPs, the speed the jet should have been reaching, the airflow over that straight wing was definitely hitting the critical Mach number. It was guaranteed to form those dangerous shock waves.
Okay, so he's pinpointed the problem with precision. The air going over the straight wing hits the sound barrier too soon. Now, the brilliant part. How does sweeping the wing back fix that?
It's beautifully elegant physics, actually. When you sweep a wing backward, the airflow doesn't hit the leading edge perpendicularly head-on anymore.
It hits it at an angle.
Right. So the air effectively has to travel a longer path across the wing chord, diagonally. Think about the component of the airflow that matters for creating those compressibility effects. It's the component that's perpendicular to the leading edge.
Can you give us an analogy for that?
Sure. Imagine holding a plank of wood straight into a fast-flowing river. The water hits at full force, right? Now, angle that plank back, say 45 degrees. The water still flows at the same speed, but it glances off the plank more easily. The force perpendicular to the plank's edge is reduced.
Okay, I think I get it. So the wing is kind of tricking the air. By angling back 18.5 degrees, the wing sees an airflow component perpendicular to its leading edge that is slower than the actual speed of the plane.
That's exactly it. The air is still rushing past at, say, 850 kph. But because of the sweep angle, the effective velocity component that triggers the shockwave formation is significantly lower. Mutka calculated that 18.5 degrees was sort of the magic number.
Why that specific angle? Not 10, not 30.
It was a careful balance. He needed enough sweep to significantly delay the shockwave formation, to push that critical Mach number higher. But he couldn't make it too steep because a highly swept wing introduces other problems, structural stresses, tricky low-speed handling characteristics. 18.5 degrees was apparently just enough, but not too much. Structurally conservative, aerodynamically effective.
And what did his calculations predict? How much faster could the ME-262 fly safely with this 18.5-degree sweep?
His numbers showed it would delay the onset of those severe compressibility effects, the shaking, the Mach tuck, by about 150 kilometers per hour.
Wow, 150 kmph. That's nearly 100 miles per hour faster.
A huge jump. That seemingly small angle change would unlock the ME-262's true potential. It would allow the plane to safely push towards 900 kilometers per hour, maybe even a bit more, without trying to tear itself apart or dive into the ground. It was the solution.
It's just staggering to think about the risk he took. We mentioned he worked on this in secret.
For 3 weeks. Only at night, using scrap paper, apparently personal notebooks, deliberately avoiding the official logged, numbered design sheets.
Because if it was logged?
You'd have to explain it. It
Yeah.
would immediately trigger alarms, conflict with the RLM mandate. The sources are clear. This kind of technical insubordination, especially on a top priority weapons project during wartime, the consequences could have been severe. Prison, or potentially much worse. He was literally betting his life on his calculations being right.
He had the theory, he had the drawing. Now he needed to prove it worked in the real world.
Which brings us to the secret test flight. Okay, this is where the story really diverges from the official Luftwaffe records. If you look at the standard histories, the accepted timeline, you'd see the swept-wing ME-262 dismissed as a theoretical concept, maybe a footnote.
Right. The official line is never built, never flown during the war. The standard model, the one that actually saw service from July 1944 onwards, had the mandated straight wings. End of story.
But the truth was hidden away for decades.
Until researchers digging deep in the German Federal Archives in Freiburg found the smoking gun, a specific Luftwaffe test report.
What did this report say? What were the key details?
It's dated April 9th, 1943. That's crucial, just about 3 weeks after Mutka finished his secret calculations. The aircraft identified as ME-262 V9. That's the 9th prototype built.
V9, okay. And the explosive part?
It's in the notes section. Just a few concise but utterly damning words. Modified wing configuration. Unauthorized test. Results classified.
Wow. Right there in black and white. Couldn't be clearer. The modification did happen. It was not approved. And the results were so significant, they had to be immediately classified, hidden away. It confirms Mutke's story completely.
So how does a junior engineer working in secret actually get a brand new set of wings built and attached to a prototype jet fighter without anyone noticing?
Well, it probably wasn't a whole new set of wings. That would be too complex, too obvious. The thinking is it was a modification of the existing wings on V9.
Ah, modifying the existing structure.
Exactly. It speaks to maybe a level of, let's call it quiet desperation, or perhaps solidarity on the factory floor. Mutke must have convinced someone important in the fabrication shop, a foreman, maybe a trusted team of skilled workers.
He needed allies.
Definitely. He needed people willing to look the other way, or maybe actively help. The theory is they likely falsified a work order. Maybe V9 was scheduled for some routine maintenance or minor repairs around late March, early April 1943.
Creating a window of opportunity.
Precisely. A period where the aircraft was disassembled anyway. Our sources mention some unusually vague maintenance logs for V9 around that exact time. It provided the perfect cover to quietly modify a section of the wing, incorporating that 18.5-degree sweep, and then put it all back together.
Okay, so he's managed the impossible. He has the modified V9 prototype sitting on the tarmac. The physical proof exists. But now he needs the ultimate validation. He needs a pilot.
And not just any pilot. He needed the pilot. The one person whose opinion on the ME-262's handling characteristics was unimpeachable. Chief Test Pilot Fritz Wendel.
Wendel, we mentioned him earlier, world speed record holder in 1939, right? He flew an ME-109 variant at over 755 kph.
That's the man. He knew the ME-262 inside and out. He'd experienced the compressibility issues, the Mach tuck, more than anyone. He understood the plane's limitations perhaps even better than the designers back in Berlin did.
But the risk for Wendel, getting into an unauthorized, radically modified experimental jet.
It was enormous. Wendel was a Luftwaffe hero, a public figure. If this secret flight went wrong, if he crashed, or even if they were just caught, his career would be over instantly. Court-martial, disgrace, maybe worse.
Why did he agree to do it?
Probably a combination of factors. He knew the straight-wing version was flawed. He likely felt the pressure to find a solution just as much as Mutke did. And perhaps Mutke's careful calculations, the sheer logic of the physics, convinced him it was worth the risk. He trusted the math, and he desperately wanted the plane to work properly.
So the stage is set, April 9th, 1943. Fritz Wendel climbs into the cockpit of ME-262 V9, the one with the forbidden swept wings. This is it. The next few minutes could change everything.
Just 11 minutes, according to the classified report and later testimonies. 11 minutes to prove Mutke right or wrong.
Take us through that flight. What happened?
Wendel gets his clandestine go signal. takes off, climbs to about 2,000 meters, roughly 6,500 feet, gives himself a bit of altitude, a safety cushion, just in case the mock tuck was still there or worse.
Smart move. Then he levels off.
Levels off and pushes the throttles forward, accelerating past the official RLM limit of 480 kph. Keeps going. 500, 600, 700 kilometers per hour.
That's the zone where the unmodified plane would start to shake violently, where the controls would stiffen.
Exactly. That was the terror zone in the standard ME-262. But in V9, with the swept wings,
What did Wendell feel?
according to his later accounts, confirmed by the report's implications, nothing. Or rather, an unnerving lack of drama. No vibration, no shaking. The controls remained smooth, responsive, tactile in his hands. The nose stayed perfectly level.
The sweep was working, the shock waves weren't forming, or at least not as severely.
They were being delayed, pushed to a higher speed, just as Mucke's math predicted. So Wendell, feeling the plane behave beautifully, did the logical thing. He pushed it further.
Into territory no ME-262 had ever safely reached before.
Way beyond. He pushed to 800 kilometers per hour, still smooth. Then 850 kph. That's over 520 miles per hour. He held it there, reportedly for about 6 continuous minutes at these unprecedented speeds.
6 minutes flying faster than any German jet had ever flown without trying to kill the pilot.
Exactly. He apparently performed some gentle turns, tested the elevators, the ailerons. The jet responded predictably, smoothly. It was behaving like a proper high-speed aircraft. Mucke's calculations weren't just theory anymore. Wendell had proven them in the real world, thousands of feet above the ground.
He brings V9 back down, lands safely, the secret test is over. What's the immediate debrief? What did Wendell say to Mucke?
His feedback was apparently quite concise, very pilot-like, but absolutely definitive. He told Mucke it was, quote, the smoothest high-speed flight he had ever made.
The smoothest high-speed flight ever. That's it. Proof positive.
Undeniable proof. The data was in the flight recorder traces. The testimony was from the chief test pilot himself. The ME-262 was supposed to be a 900 kph aircraft. And thanks to Hans Mucke's forbidden blueprint and Fritz Wendell's risky flight, it finally, briefly was.
They had the answer. The fatal flaw was solved. So what happened next? Surely they rushed this design into production.
You would think so. But what happened next is perhaps the most frustrating part of this whole story. So Mucke's got the proof. Wendell's testimony, the flight data from V9, it clearly shows the swept wing works, solves the compressibility issue, unlocks the plane's true speed. This should have been a game changer.
Yeah, you'd expect emergency meetings, RLM changing course, ordering immediate implementation.
But instead, silence. The success was met with what can only be described as a political and bureaucratic deep freeze. The swept wing design, proven in those crucial 11 minutes, was deliberately suppressed, buried.
Why? Why bury something so obviously beneficial, especially during wartime when you need every advantage?
It comes back to that paralyzing environment we talked about in 1943. Implementing Mucke's solution, however brilliant, required two things that were simply impossible for the leadership at Messerschmitt and the RLM to stomach.
What were they?
First, they would have to officially admit that the RLM's own mandate, the strict order for straight wings, was fundamentally wrong, technically flawed from the start.
Admitting failure to the higher-ups, never popular.
Especially not in that regime. And second, even worse from a production standpoint, actually building the swept wing version would mean another massive delay. They'd have to halt the existing production plans, retool jigs, rewrite manuals, retrain workers. A huge redesign effort.
And delay was the one thing Hitler absolutely wouldn't tolerate, especially with his bomber obsession.
Precisely. That political pressure from the top was the killer. Hitler wanted planes now, specifically bombers or fighter bombers. Any manager reporting upwards that they needed to pause everything for a year to fix an aerodynamic issue the RLM had ordered them to ignore, well, that manager was basically signing their own death warrant, professionally and perhaps literally.
So it boiled down to fear. Fear of admitting error, fear of causing delays, fear of Hitler's reaction. They chose bureaucratic safety over technological superiority.
That seems to be the consensus. No senior figure at Messerschmitt or the RLM wanted to be the messenger delivering that particular piece of news. Think about it. Good news, Herr Minister. We've solved the jet's biggest problem. The bad news is the solution came from a junior engineer who violated your direct orders, proving our initial design mandate was wrong, and implementing it will delay the entire program by a year, further angering the Fuhrer.
Yeah, not a career-enhancing presentation.
Not at all. It was simply safer, politically, for everyone involved in the existing chain of command to classify Wendel's test results, pretend the V-9 flight never happened or wasn't significant, and just push ahead with the flawed but officially sanctioned straight-wing design. Claim it was necessary for expediency. The truth was just too dangerous, too inconvenient.
And the physical evidence, the V-9 prototype itself.
That's where it gets even darker. The test report from April 9, 1943 was stamped classified and vanished into the archives. And then, just 3 months later, in July 1943, the ME-262 V-9, the only prototype ever fitted with Mudke-swept wings, was officially reported as destroyed.
Destroyed how?
Conveniently destroyed, as many historians note, during an Allied bombing raid on the Messerschmitt facility. The one unique airframe that proved the straight-wing mandate wrong was suddenly, permanently gone, wiped from the record.
So the solution was physically eliminated along with the report?
Effectively, yes. The evidence was erased, and the program continued down the officially mandated but aerodynamically compromised path.
And here's the stunning irony we mentioned earlier. The plane they did field, the straight-wing ME-262 that entered service in 1944, even though it was deliberately hobbled, limited to maybe 540 kilo-kVh operationally to avoid the worst of the mock tuck, it was still revolutionary.
Absolutely terrifyingly effective, even in its flawed state. Pilots nicknamed it the Sturmvogel, the Stormbird. Allied pilots had never encountered anything like it. Its speed, even limited, and its cannon armament were devastating.
The kill ratios were incredible, weren't they?
Astonishing. Sources generally agree on something like a 5.1 kill ratio in its favor against Allied fighters, like the P-51 Mustang and Spitfire. Think about that. An aircraft operating significantly below its potential speed, constantly hampered by instability near its limits, was still dominating aerial combat.
It just highlights how fundamentally game-changing the jet engine itself was.
And it underscores the tragedy of suppression. Imagine if the Luftwaffe had fielded Mudke's version in 1944, or even early 1945, a 900 kph fighter, stable, maneuverable at speeds Allied planes couldn't hope to match. It could have had a significantly greater impact on the air war.
Those operational limits imposed by the straight wings must have been incredibly frustrating for the pilots.
Constantly. They always had to be mindful of that invisible speed boundary. Pushing too hard in a dive or even level flight could trigger the instability. It limited their tactical options. They often couldn't fly at the optimal high altitudes where jet engines perform best because they needed denser air lower down to maintain control authority when near the compressibility limit. It increased fuel consumption, reduced range, and effectiveness.
It was a compromised masterpiece, held back by a political decision made a year earlier based on fear and expediency.
Fundamentally, yes. The aircraft that flew was a shadow of what the V-9 proved it could be.
Let's bring in the post-war voices. They add a final, poignant perspective. Mutke himself survived the war.
He did. He actually became a commercial airline pilot later in life. But crucially, during post-war Allied interrogations and later interviews, he confirmed the whole story. He detailed the secret calculations, the modification of V-9, Wendel's flight, and the subsequent suppression. His testimony provided the crucial human element that validated the archival discovery of that classified report.
And Wendell, the pilot who flew the V-9, did he ever speak about it?
He did, years later. And his words really cut to the heart of the tragedy. He was asked about his most memorable flights. He stated quite clearly that the swept-wing ME-262 V-9 was, and I quote again, "the finest aircraft I ever flew."
The finest aircraft he ever flew. High praise from a world record holder.
Absolutely. He understood exactly what potential had been squandered, and he offered a chillingly blunt assessment of why it happened. He said, "Politics killed better men than bureaucracy ever did."
Wow, that really says it all.
It's the perfect epitaph for this whole episode. It captures the frustration of engineers and pilots who saw a clear, scientifically proven solution rejected not for technical reasons, but because of political maneuvering and administrative cowardice. The math was right, the flight proved it, but the system couldn't handle the truth.
A classic case of technological potential being stifled by the system meant to develop it. But the story, as you said, doesn't end there. The physics didn't care about bureaucracy.
Right, so the V-9 might have been officially destroyed, the report locked away, Mudke's design seemingly dead and buried within the collapsing Third Reich. But physics has a way of resurfacing. The idea was too powerful to stay hidden forever.
Exactly. The end of the war in 1945 changed everything. As Allied forces swept across Germany, they weren't just capturing territory, they were capturing intelligence, specifically technological secrets.
Operations like Paperclip in the U.S. and similar efforts by the British and Soviets.
Massive efforts. Teams of scientists and intelligence officers descended on places like the Messerschmitt facilities, research labs, RLM archives. They vacuumed up everything: blueprints, wind tunnel data, test reports, theoretical papers. Tons of documents were crated up and shipped back home for painstaking analysis.
And this wasn't just about rockets, right? They were grabbing aviation tech, too. Oh, absolutely. They knew the Germans were ahead in jet propulsion and high-speed aerodynamics. And amongst this avalanche of captured data, this treasure trove of advanced and sometimes suppressed German research.
Someone finds Mutke's work.
Someone finds the drawings,
Yeah.
the calculations, the data showing the clear link between wing sweep and delaying compressibility effects at high subsonic speeds. The very concept that was too politically inconvenient for the Luftwaffe in 1943 suddenly became incredibly valuable to the victors in 1945.
It must have been like finding a Rosetta Stone for high-speed flight.
It really was. Because suddenly, engineers in the U.S. and the Soviet Union, who were grappling with the exact same compressibility problems as their own jet designs got faster, had a clear, proven solution handed to them.
So let's trace that lineage. It's almost immediate, isn't it? Where does this captured German research, including Mutke's swept-wing concept, pop up first?
Look stateside. By 1947, just 2 years after the war ended, North American aviation is deep in development for a new jet fighter. They need something to counter potential future threats, possibly Soviet jets, also based on German tech.
This becomes the F-86 Sabre.
That's the one. And the F-86 Sabre is designed from the outset with highly swept wings, 35 degrees actually, significantly more sweep than Mutke's initial 18.5 degrees because they were aiming for even higher performance, pushing closer to Mach 1.
And they acknowledged the source.
North American engineers were quite open about it at the time, citing captured German research and German aerodynamic data as the direct inspiration for adopting the swept-wing configuration. It wasn't guesswork. It was based directly on the work people like Mutke had done.
Meanwhile, on the other side of the nascent Iron Curtain,
The Soviets are doing the exact same thing. They captured their own batches of Messerschmitt documents, perhaps even engineers. Their design bureaus, like Mikołaj and Gurevich, are analyzing the data.
and they come up with
The MiG-15, unveiled in 1948. And what's its defining feature? Sharply swept wings, again around 35 degrees. Almost a parallel development, driven by the same captured German concepts. Both superpowers instantly recognized that for serious high-speed jet fighters, the straight wing was dead. The swept wing was the future.
which leads to one of the most striking ironies in military aviation history.
It really is profound. Fast forward just a couple more years to 1950, the Korean War breaks out. And what are the two iconic premier jet fighters dueling in the skies over MiG Alley?
The American F-86 Sabre and the Soviet MiG-15.
The two direct descendants, not of the ME-262 that actually flew in combat with its flawed straight wings, but descendants of the solved ME-262 concept embodied in Mutke's suppressed V-9 design.
So the core aerodynamic principle that the Luftwaffe rejected in 1943 is now the key technology enabling both sides in the first major jet versus jet conflict.
It's incredible. Both the Sabre and the MiG-15 could comfortably exceed 1,000 kilometers per hour, pushing towards the sound barrier, precisely because they used the swept-wing principle that Mutke had proven 7 years earlier. The innovation rejected by its originators became the cornerstone of their rivals' air power just half a decade later.
And from that point on, the swept wing just becomes standard.
Utterly standard. It became the non-negotiable, fundamental design feature for virtually every transonic and supersonic aircraft developed anywhere in the world for the next 70 years. Think about it: the F-4 Phantom, the F-16 Fighting Falcon, the F-15 Eagle, the F-A-18 Hornet, the F-22 Raptor.
On the Soviet-Russian side, the MiG-21 Su-27 flanker family, MiG-29.
European designs like the Tornado, the Eurofighter Typhoon, the Dassault Rafale, commercial airliners too for that matter, they all owe their ability to cruise efficiently at high subsonic speeds or push through the sound barrier to that basic principle of sweeping the wings back to delay compressibility drag and Mach tuck.
All tracing their design DNA back to that secret calculation done on scrap paper in Munich in 1943.
It's a powerful testament, isn't it? Foundational physics, correctly applied, is so potent that even if it's suppressed by politics or bureaucracy, it will eventually find its way out. It might take a war ending or documents changing hands, but the science itself is undeniable. It found new engineers, new nations ready to embrace it.
The ultimate vindication for Mutke's math, indeed. Hashtag, tag, outro.
So as we wrap up this deep dive, there's still that one lingering question, a small loose end that adds a final layer of mystery to this whole affair. What really happened to the ME-262 V9?
Right. The official record says, destroyed in a bombing raid, July 1943. Case closed. But as we touched on, there's this nagging detail. No confirmed wreckage of V9's specifically identifiable parts matching that unique prototype has ever been found or documented.
Which seems odd, given how meticulously wreckage was often analyzed, even during the war.
It does seem a bit too neat for some historians, given the extreme political sensitivity around Mötke's design, the lengths they went to classify the report and suppress the findings. Well, speculation arises.
What kind of speculation? That perhaps the V9 wasn't just hit by a random bomb. Maybe it was deliberately targeted for destruction on the ground during the chaos of a raid. Or, even more intriguingly, perhaps it wasn't destroyed at all in the way we think. Meaning, maybe the unique swept-wing components were carefully removed before any bombing. Maybe the crucial parts, the physical proof of the forbidden design, were hidden away somewhere. Dismantled, buried on the factory grounds, sunk in a nearby lake. Who knows? Ensuring that the actual hardware embodying Mötke's success couldn't fall into the wrong hands, whether Allied hands later or even rival factions within the German system at the time.
A final act of burying the evidence, perhaps literally.
It's speculation, of course. We'll likely never know for sure. But whether V9 was incinerated by Allied bombs or deliberately hidden by German bureaucracy, the core lesson for us, for you the listener, remains incredibly powerful. Which that fundamental physics, the truth revealed by calculation and experiment, eventually overcomes human obstacles like technological inertia, political fear, and administrative resistance. Mötke's work, validated by Wendel's flight, held more lasting truth and impact than the entire official policy of the RLM at that time.
It was a solution that arrived before its political environment was ready to accept it.
But the concept itself was so right, so fundamental, that it guaranteed its own eventual emergence. It just needed different circumstances, different engineers in different countries to finally bring it fully into the light a few years later.
So let's leave you with a final thought to consider, something building on this story. What other breakthroughs, what other inconvenient technical truths might be sitting out there right now?
Yeah, think about it. Are there potentially game-changing innovations, maybe in energy or medicine or material science, that are currently classified? Or maybe just ignored, simply because they challenge established protocols, threaten existing industries, or don't fit neat bureaucratic timelines or political narratives?
Are there modern-day Hans Mötkes, maybe working late tonight in a lab or hunched over a computer, who have found a solution that the system isn't ready for? Solutions just waiting for a crisis? Or maybe just the slow passage of time to finally prove their undeniable worth?
That's the kind of hidden innovation, often born out of necessity or defiance, that truly changes the world. Sometimes delayed, maybe even suppressed for a while, but ultimately, if the science is sound, never permanently denied.